In this illustration, we'll discuss about time between reception of minimum and maximum frequency. Here we are given that a sound source is moving along a horizontal circle of radius r at a speed u, and a stationary receiver lies in same plane at a distance d which is greater than r, that is outside the circle from the center of circle. It is observed that receiver receives minimum and maximum frequencies of sound periodically, and we are required to find the time after receiving minimum frequency the detector will receive the maximum frequency. Here if we draw the picture of the given situation in which we are given with a circle of radius r in which a source is moving, and this is the position where a receiver is placed, and the distance of receiver from the center is equal to d. So in this situation, when the source is moving, we can say the receiver will receive maximum frequency when source will be located along the tangent line passing through receiver. If this is the source and it is moving towards receiver at a speed u, receiver will be receiving a maximum frequency, and when the source is receding away from receiver at this tangent in this direction with the speed u corresponding to this position of source, receiver will receive minimum frequency. So here we can write this corresponding to the maximum frequency line, this corresponding to minimum frequency line. In this situation, if we talk about these two locations, if these are at an angle theta from the line joining the center of circle and receiver, then we need to find out the time after receiving minimum frequency the detector will receive the maximum frequency. So if this time t1 when the receiver will be receiving a minimum frequency, the time in which source will travel along this path and reaches over here, this is the position where it receives maximum frequency, and say it reaches over here at time t2, then we are required to find t2 minus t1. So here we can write a receiver will receive maximum frequency from source corresponding to its position x. This position we can consider as x, and minimum frequency from source corresponding to its position y. This position we can consider as y. So here we can write time taken by source to go from y to x position is, this is the time after which receiver will receive maximum frequency after it receives minimum frequency. This time we can simply write as the angle traversed by the source here is 2 pi minus 2 theta. So we can write it 2 pi minus 2 theta multiplied by r divided by u. And in this situation, value of theta we can directly write in this diagram as this cos inverse of r by d. So here we can write the time is equals to 2r by u multiplied by pi minus cos inverse of r by d. This is the result of this problem, the time after which a receiver will receive maximum frequency from the point of minimum frequency.